In this video, we will generate the Taylor-Maclaurin series sum of the Gaussian function and the Gaussian integral. We begin with the Gaussian function, starting with the phi function of the Gaussian function, which is array formula of the phi function. And the error function, which is array formula ERF of the x values. And the Taylor-Maclaurin series sum of both, where x is the summation of a times x to the power n plus 2n plus k, where k is 0 or 1. So data validation, list of items, 0 if it is the Gaussian function, 1 if it is the Gaussian integral. So we can start with 0. Now the Taylor-Maclaurin series sum, and the value of n is from 0 to infinity. So we'll start from 0 to infinity. 16 is good enough. And the coefficient, the expansion coefficient. So R formula minus 1, that is the quantity minus 1 plus k raised to the power n. That's our n. So we'll copy this value of n times the second item is double factorial. So double factorial 2 times n. That's 2n minus 1. Double factorial of 2n minus 1. So we have completed the numerator. Now we continue with the denominator. The denominator is factorial 2n plus k. So factorial 2 times n plus k. And enter. So we can correct this error, the first item. So if k is 0, it should be 1. So we correct this. So if n is 0, and it should be 1. Otherwise, calculate. Now it's corrected. Now we continue with the Taylor-Maclaurin series sum. Expansion of both. So our formula, series sum of the x values raised to the power 2n plus k. 2n plus k starts from k, incremented by 2n. So 2n is 2, 4, 6, 8, so the increment is 2. And the coefficient, it will be this range, the a values. And we'll chart this. Insert chart. And we use scatter chart. And column A as label, row 1 as header. We customize the series to show the trend line. Polynomial to the 8th degree. And for the label, use the equation. For the legend, position at the bottom. We don't need a title here because we have already the equations. So, and we need a space. And for the series, we don't have a yellow color. We change that to green. Change this to green to match our data set. And for series, the point size maximum. Except for the red, except for the expansion, where the point size is none. There's no point size, but the line thickness will be maximum. That's our line thickness. So here's the trend line and polynomial of the tree: the expansion, the function, and the integral, the Gaussian integral. So we can toggle this. So if you toggle this at 0, this Gaussian integral should be equal to this. So we have to change this. Multiply by square root of pi, 2 pi, 2 pi. So that is square root of 2 pi. So that's square root of 2 pi. Now they're the same. And we toggle this to 1. This green should be on the red. So we have to complete this. We multiply by, the first part is square root of pi. Then enter. And the second part will be multiply by 0.5 times 0.5. Now they're on the trend line. They're all in the same trend line. We toggle this. Now they're all the same trend line. We calculate the polynomial regression coefficient using Linest. To do that, we complete the Linest matrix starting with the power. This will be transpose 0 to 8. And the elements of the matrix are the formula of the x values raised to the power 0 to 8. Then enter. Now we calculate Linest. So Linest, you can use Linest on the Gaussian function dot y and dot x. And Linest again on the expansion dot y and dot x. And finally, Linest on the Gaussian integral dot y and dot x. And let's compare. So coefficient of x to the 0, let's compare. Coefficient of x to 0, 1, 1, 0. So 1, 1, 0. Coefficient of x, that's 0, 0.997. Coefficient of x squared, minus 0.5, minus 0.5, and 0. Coefficient of x cubed, 0, 0, and x cubed minus 0.313. Coefficient of x to the fourth, 0.123, 0.123, and 0. Coefficient of x to the fifth, 0, 0, 0.0696. Coefficient of x to the sixth, minus 0.0182, minus 0.0182, and 0. Coefficient of x to the 7, x to the 7, 0, 0, 6.54 times 10 to the minus 3. Coefficient of x to the 8, 1.28 times 10 to the minus 3, 1.28, and this is 0. Let's toggle this to 1. Coefficient of x to the 0, 1, 0, 0. Coefficient of x, 0.997. Coefficient of x squared, minus 0.500. Coefficient of x cubed, minus 0.313, or 0, minus 0.313, minus 0.313. Coefficient of x to the fourth, 0.123, and this is 0, 0. Coefficient of x to the fifth, 0, 0.0696, 0.0696. Coefficient of x to the sixth, minus 0.182, 0, 0. That's 0. X to the 7, that's 0, 0, 6.54 times 10 to the minus 3. Coefficient of x to the 8, 1.28 times 10 to the minus 3, 0, 0. So we can toggle this from 0 or 1. This completes the use of double factorial to generate the Taylor-Maclaurin series sum of the Gaussian function and the Gaussian integral and its Linus polynomial regression.